hello again. This time we're going to look at sprint number 19. All right, in this problem, Horace has an unfair coin that can land on heads or tails. He notes that if he flips it 9 times, then the probability of getting 9 heads is equal to the probability of getting 7 heads and 2 tails. What is the probability that the coin will land on heads after a single flip? Express your answer as a common fraction. Okay, so what are we asking for? The probability that the coin will land on heads after a single flip. That seems like the kind of thing that could have a variable. Let's call it h for heads. So h is some probability. It's going to be somewhere between 0 and 1. And hopefully it's going to be a common fraction, right? Okay, if he flips his coin 9 times, the probability of getting 9 heads. What is the probability of getting 9 heads? Well, it's a probability of h that he gets the first head. It's a probability of h times h that the first 2 are heads. So to have all 9 of the flips be heads, it's going to be h times 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 h, or h to the 9th. Okay, so that's the probability of getting 9 heads. We know that that's equal to the probability of getting 7 heads and 2 tails. What's the probability of getting tails? Should we call it t for tails? Let's not call it t for tails. Let's instead say 1 minus h, because we know his coin is going to land on either heads or tails, meaning if it doesn't land on heads, then it must land on tails. Or in other words, if we add the probabilities of getting heads and tails, we get 1, because it is certain when we flip this coin that it will land on either heads or tails. Okay, so here's our 7 heads. We've got them on the right side of the equal sign, and 2 tails, so that's times 1 minus h times 1 minus h. And is that it? Is that everything? No. That there is the probability of getting 7 heads and then 2 tails in that order, but we don't care about the order. So now we also have to multiply by the number of orders in which you can get 7 heads and 2 tails in 9 flips. All right, well, the easiest way to think about that is we've got our 9 flips and we pick 2 of them to be tails. So 9 choose 2. All right, what's 9 choose 2? It's 9 times 8 divided by 2, right? Pick 2 things, order doesn't matter, so we divide by 2, which is 9 times 4, which is 36. So we stick that in there on the right side. Probability of getting 7 heads and 2 tails is the 7 heads times the 2 tails times the number of ways we can order this. You may be thinking, where was that on the left? We didn't have any kind of ordering on the left. But actually, if we have 9 heads, there is only one way to order them, right? It's going to be 9 heads, because there's really not much to rearrange. Okay, that's a lot of h's. Can we get rid of some of these h's? We can divide them through the equation by h, because we're quite sure that h is not 0. So we're going to divide each side by 7 of these h's, which leaves 2 on the left and gets rid of all 7 on the right. H times h is 1 minus h times 1 minus h times 36. Now, we could go ahead and multiply out that thing on the right. That's actually how I first did it when I was looking at this. And that will get you to the answer, but it is a lot harder than the kind of clever thought here, which is h times h squared, that's a square. 1 minus h times 1 minus h, that's also a square. And 36, that's 6 times 6, that's also a square. So we could take the square root, right? We rearrange, and we see that this thing on the right is 1 minus h times 6. Take the square root of both sides of this equation, get rid of half of each side. And now we have h equals 1 minus h times 6. Multiply through, h is 6 minus 6h. And this is pretty doable from here, right? Add 6h to both sides and then divide through by 7 to get h is 6/7. And we were smart enough to make our variable be exactly what we were looking for as the answer. So we've got the probability that the coin will land on heads after a single flip, expressed as a common fraction, is 6/7.
This is Tim. Hope you're enjoying our videos. If so, you know what to do: like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.